Right, chapter 3 begins with integration by parts. So if you get an integral that you have to have as a multiple of different things, sometimes it's easier to just break them apart using this theorem 3.1 above. So if you have two different functions, u and v, that you can have a product of these things into. If you take the integral of u with respect to dv equals uv minus the integral of v du. So kind of the process for this is you determine what you want to have as your u first, and the other part you pair up with the dv part. So that's kind of the method for how to do this. A lot of times just the dv could be something like just the dx, but it'll be dx and something. All right, down below here we've got this rule called LIATE. These refer to the logarithmic functions, inverse trig functions, algebraic functions, trig functions, and exponential functions. Typically, if you have these things, you are supposed to look at the start of the list, whichever comes earlier in the word LIATE or the acronym, or earlier in this list is what you should try to use as your U. You should use that as your. However, this does not always work. So you may have to go a different way if you realize that it's not working. All right, so your homework gives you some questions. I've put one down. It says find the integral by using the simplest method. Not all problems require integration by parts. This one is going to. However, they've used a v instead of an x. I'm going to just change this equation, or change this to be the integral of x and then sine of x dx. I don't want you to get confused with the u's and the v's. You can use any two letters for u and v that you want, similar to u's substitution. You can use a v substitution if you want, that sort of thing. But I'm going to, for the first problem, I'm going to change what the book has, and I'm going to just make it x. Okay, so looking at this list here, we have trig functions. We have a trig function, and we have an algebraic function. It's just x. Because a comes before t here in the list, we're going to try to make our u the algebraic function. So let's do that. So we're going to let u equal our algebraic function, which is just x. Now, like a normal u substitution, we're going to take the derivative of this. So we're looking for du, and that's just dx, or 1 times dx if you prefer. Now, what makes this a little different from our typical substitution problem or anything like that is now we have a dv that we begin with. We're making the dv equal the rest of it. So this part will be dv, and this part is our u. So dv is sine of x dx. And now we want to go from a dv to a v, so we're, instead of taking the derivative here, we're doing the opposite procedure, the inverse procedure. We're taking the integral. So the integral of sine of x is negative cosine of x. So again, if you take the derivative of cosine, you get negative sine. Negative times that would be just straight up sine. So now we've got our 4 pieces, and now we can use that equation 3.1 or theorem 3.1. Let me scroll down a little bit so that we can do that. Change this back to our blue. So this equals u times v, so x times negative cosine of x. That's u and v, minus the integral of v, which is negative cosine of x, times du, which is just dx. Well, we can integrate, well, what would become cosine in the same manner that we did the integral of the sine. Integral of cosine is just sine. Integral of sine is negative cosine. So this becomes x, well actually negative x cosine of x. And then we have two negatives here, so this is just plus the integral of cosine of x, or let's just do this. Let's add one more step here. The integral of cosine of x is just sine of x. Now, we have an indefinite integral, which means that this will work with any additional um, value as far as some sort of number. So we need some sort of constant c to be talked about here, and this will be our answer.